Today we're going to learn how to build threat detectors with Athena. Over the past few labs, we've learned how to run security-style queries using Athena, which in the realm of security operations, incident response, is one of our best tools for analyzing incidents. Keep in mind that everything we've covered would also translate to a commercial SIM, or Security Information and Event Management product. Today, we'll expand on the concept and learn how to use queries as threat detectors. A threat detector, it's basically an alarm. In SecOps, we talk a lot about indicators of compromise and indicators of attacks, and other signs that an adversary is trying to break in, the indicator of attack, or has broken in, the indicator of compromise. There's a ton of art and science to these, and we have various ways we can implement them. There are different techniques and places to implement threat detection, including the use of specialized tools like intrusion prevention systems and network appliances and guard duty. Yep, that's actually a threat detection service run by AWS that tracks all sorts of activities in your account to look for something suspicious based on what someone is doing, such as making a bucket public, or who's doing it, which is things like activity from known suspicious IP addresses. And if you're interested more in detection engineering, I highly recommend subscribing to the newsletter Detection Engineering Weekly by Zach Allen. We've already set up detections for things like public S3 buckets and our guard duty alerts, but what about activity based on multiple things happening that we see in our logs? The following, for example, are potential threat activities that could show up in CloudTrail, but we can't capture these with a single event bridge rule or by relying on something like guard duty unless guard duty happened to build that rule for us. For example, multiple failed API calls over a time period that could indicate someone's trying to see where privileges an identity has. Or a change in the user agent used for making API calls because maybe that indicates a credential was compromised and is now being used by an attack script. Or perhaps a sequence of actions that aren't suspicious alone, but could indicate an attack when they're all done together in sequence, such as the combination of get caller identity, followed by some describe API calls, followed by taking a snapshot of a storage volume, and then sharing that with a new account, which is what we did in our skills challenge when we were learning about Athena queries. All of this activity is in the logs, but to make them an actual threat detector, we need to figure out how to trigger those based on the activity, or trigger a threat detection based on that activity. In my examples, you probably noticed that some of them look like we could use them or identify them with a single query, while others might take a little bit more analysis. You can probably see how to run the queries yourself to look for the activity, but for threat detection, we need to run those things on a schedule. Now, this has two problems. First, you can run queries on a schedule, but what if one step of the attack happened before your window of a query? And I'm going to illustrate that in just a moment. The second is that you can't always detect these patterns with a single query. For example, you can't write one SQL query that will say, find me every time the user agent for this role changes. Let's illustrate the first point and focus on that one today. Imagine an attack with 4 steps, and I've got that on the screen here. And it's only a potential threat if we see all 4 of these steps, A, B, C, and D, happen together in a row. Now, in an ideal world, we could run queries for any user that does all of these, say, over a 15-minute period, which is what I have in this illustration. But that leads to kind of a problem. And if I scroll down here, you can see what happens if the steps occur partially in one query's time window and partially in another. Remember, we're running our query every 15 minutes and every other 15 minutes. And if the first step happens in the first window and the next 3 happen in the second window, then we're going to go ahead and miss this particular activity. Now, you're smart, you're intelligent people because you've managed to survive over 60 of these labs, so you probably have an idea here. And this is sort of how we address it, or not sort of, this is how we address this problem. What we're doing here is I've done 2 things. One is I extended my window for 20 minutes, and then I now run this every 5 minutes. So I run the query for 5 minutes for the past 20 minutes, run it for 5 for the past 20, run it for 5 for the past 20. With this overlap, No matter where these actions occur, let's go ahead and select these and move them around. If I move it earlier, well, we're still going to capture it with this window here. Even earlier, we're going to capture it with this window here. And later, we're going to capture it with this window here. So no matter what I do, I should be able to capture this activity. This is known as sliding windows. Now, how do we figure out what these windows should even be? Turns out it's actually pretty easy, just a little bit of math. Say we want to find 5 failed API calls within an hour, we just divide the detection window of 60 minutes by the number of actions, which is 5, and we run our query every 12 minutes. And this ensures that as long as those 5 things occurred within that hour, we are going to go ahead and capture it. Now, this is better than how I illustrated things, where I extended my window and then I kind of slid it by hand. Because if you do the math, you can see that I should have kept my 15-minute query window and run it every 3.75 minutes. Look, either approach is valid depending on how important the timing is. Usually for threat detection, we don't care if X actions occur in Y time frame exactly, so we can play with our windows a little bit to reduce the frequency of those queries and save ourselves a little bit of money by not running them as often. What I've illustrated here, it's just the most basic way to approach the problem, and it probably wouldn't shock you to know that there are dedicated real-time streaming data analysis tools. One of them is called Apache Flink for all sorts of advanced fun, because those are things a lot of data analysts need in all sorts of different scenarios. And we could use those tools. Or we can also do things like send the events we care about to a database like DynamoDB and run code and queries on top of that on only the events that we actually care about. Definitely some different approaches to that. Today, we're just going to focus on the simple one, where we're going to focus on implementing the sliding windows, and let's get to the lab. Today, we will use a combination of EventBridge, Lambda, and Athena to run a query-based threat detector. Specifically, we're going to look for 5 failed API calls over the past hour and use that 12-minute sliding time window that we talked about. Now, why are we using Lambda? Well, there's no other way to schedule Athena queries. It doesn't have a pre-built scheduler. Also, we want to be able to control our output and where we actually send the results. And then we're going to get fancy. We're going to transform our results into the Amazon Security Findings format before we email them off. And we're going to use that existing Security Hub alert SNS topic we did a while ago to send that to us. Now, why the Amazon Security Findings format, the ASFF? ASFF? Yeah, because that's what Security Hub uses natively in case we want to change things up later, and we can actually push our findings into Security Hub itself. Now, maybe I should have used OCSF, the Open Cybersecurity Schema format. I get that name wrong sometimes. If you happen to know what that is, but that doesn't matter for our lab purposes. ASFF is going to work well for us. Then we'll finish by running a CloudFormation template in our test account 1 that's going to create an IAM role and a Lambda function that can't really do anything, but it's going to try and do things, and that's going to create those failed API calls. Okay, to start with, let's go into our sign-in portal. And we're going to do our work in our predominantly in the security audit accounts. We're going to start off in security audit. And remember, because we're playing with Athena, it's going to be helpful to use the security full admin. Once I go in with my security full admin, I want to double check I'm in US West Oregon, make sure I'm in the correct region. And the next thing I want to do is I'm going to copy my account ID and I'm going to paste that into a temporary file. I have a clipboard that keeps multiple things, so I don't have to worry about losing it. Then we're going to go to CloudFormation. And as you might imagine, I've got a CloudFormation template that we're going to use to deploy all of this. We'll go to Create Stack. We're going to choose an existing template, Amazon S3 URL, and let me go pull that from the blog post and come on back. I've pasted in the template and go and click Next. And then for the stack name, let's call this Threat Detector. Now for the parameters, we need the account ID. Let me grab that from my clipboard. And this again is the current account ID. Could have just copied it there, pasted it there. Click Next. The reason I put it on the clipboard is I'm going to need that later for another portion of this lab. Scroll down, I acknowledge, next, scroll down, and submit. Now, as that's running, I want you to take a quick look over at the template itself. And there's a couple of things here. Yes, I did use a AI and an LLM to build this because, guys, I don't have time to code all of this stuff every week or every other week. Now, the important part here is this is going to set up a bunch of permissions that we need for everything to run. We need a new IAM role for the Lambda function, and that creates that policies and ties all of that stuff in. Then we have the Lambda function itself, and the Lambda function is Python as usual. Within here, there's a whole bunch of stuff. There's a lot going on, and I encourage you to look through that. It's not something where I'm going to go through all of it for you. And we can actually put in potentially, I coded this up so we could put in multiple threat detectors, although then that starts to get a little long in terms of our runtime. And but we've got ways that we could actually pick which one we run. This is the important part. This is the query. What we're going to do is our Athena query is we want to select, so the user identity, and then now it's going to be account. This is going to make sense in a moment. And we're building a couple of arrays here. One is all the actions that failed, so what the user attempted to do, so that's the event names, and all of the user agents. This is actually going to help us in our investigation. It gives us more information on what we need. You'll actually see this in the results. We're going to pull the time of the first failed event and the time of the last failed event. This comes from our table names, standard table name stuff. That's just, it's built into our Lambda function here. And this is where we get fancy. So, 75 minute, that is supposed to be every 12, the current timestamp, it's supposed to be every 60 minutes. And I guess okay, I had to double check myself. For the video, this is going to be a little off because I had made some changes into the code to run it for every hour. This is actually running every 75 minutes in the one in my environment. Don't worry, when you see it in your environment, it's going to run every hour. And that's the core of the code. Going back here and looking at it is that it's basically anything in the last 60 minutes, ignore that it says 75 in the video, and if the errors are access denied, unauthorized or unauthorized operation, unauthorized access, and there is a user identity, we're going to group by the username and we're going to include the count. Now, this is a fancy query. You could pull this out, you could clean it up, you could run it in your account. And if you do manually run that query in your account, it actually gives you a list by user identity for anyone that has more than five failed API calls in that time window, and then gives us that other information. It's going to give us a list, an array of what were the failed API calls that they attempted to do, what were the user agents that were involved, what was the start time, the first detected within that window, and the last detected. Okay, with all that in place, then what that CloudFormation template is doing is it's creating that event bridge rule, and it's going to run this every 12 minutes. This is how we build our sliding windows. I'm going to go ahead, I'm going to pause the video. Oh, nope, my creation is complete. So mine is all up and running in my account at this point in time. Now there's one problem. This is failing. I can tell you this is going to fail because we have a bucket policy on our S3 bucket where the Athena queries are running against, and the IAM role for this Lambda function does not have permissions to access that bucket policy. We need to go ahead and fix that bucket policy, and this is going to make much more sense in just a moment. So let me close this window out. And if you remember, the S3 bucket for our CloudTrail logs lives in log archive. Let's go in with admin access to the log archive account. And we're going to go into S3. And this is our CloudTrail logs. We'll click on it. And we'll go to permissions. And if I look at my bucket policy here, you'll see that the security full admin has access to this bucket. But if I scroll down, you're going to see no place does the Lambda function we need have access, and that's going to break its ability to run those Athena queries. Thus, we need to edit this. So we're going to go to edit, and this is where you're going to need that account ID again, and it's going to get, this is one of the more complicated edits that we've had to do in any of these labs. Let me switch over to the blog post to show this. What I've done here in the blog post is I've pulled out that snippet at the top that we need to edit. And this is what it looks like. Now, this is not what you're going to copy and paste. But the important part here is you have this ARN, this Amazon resource name, which is going to be different in every one of our accounts. So you need to copy this and put that into whatever text file where you also have your account ID. Then you scroll down and you copy this text out, this entire piece. I'm going to take all of this, copy, and put this into my text file. Let's make that text a little bit bigger for those of you watching at home. And then within the text file here, I have to place that ARN in first. I can't remember if I already copied that. Let me go ahead and I will get that again. Now I cheated. Mine's in the actual blog post, so you get to see what my roles are. Yep, there's no secrets here. If you can figure out how to compromise that, let me know. I'd be very interested. That'd be a new kind of an attack. So I'm going to paste that ARN in there. And then I need my account ID. And let me pull that off my clipboard. Let me highlight that. And I pasted that in. So I have this top section here. Everybody has the same name for that threat detector role. It's just that our AWS IAM Identity Center role is going to be a bit different for each of us. You'll notice what I've done is I've made this, if you know JSON, this makes it into a list. It's an array, item 1, comma, item 2, comma, of the principals. Now, let's select all of this and we'll go back into our policy. Let's see, had I clicked edit policy? I did. You can see line 9, this is the key, line 9 and above, because everybody's policy should be identical. I'm going to highlight all of that, and I'm going to paste over it. And it looks good to me. You'll notice there's no errors here, and I have both of those roles appearing. Okay, so with that in place, let's go and save changes. The bucket policy is all set. There were no errors. These are my account IDs. I know this is in my account. Make sure they're your account IDs in your accounts. Close that window. Now we're going to go ahead and generate some activity. Go into test account 1 and administrator access. Then going back into the blog post, there's another CloudFormation template. Double check US West Oregon, go to CloudFormation and create stack. Choose the existing template. Let me go grab that. When I paste this in, notice a really important part. This says lab63-test. You don't want to do the same template twice. It would error out. We'll go to next, give it a name, delete me works so you don't forget, because you're not going to want to leave this running for very long because it's generating a lot of activity and logs. We'll click I acknowledge because we have to create an IAM role. So this is just going to create a Lambda function that tries to do things that it can't do. Click submit. That's running. Okay, I'm going to go ahead and pause. I'm walking away from my desk. I'm going to come back in like maybe 20 minutes. And by then, hopefully I should have my alert. Remember, this is now deploying. Within a few minutes, it'll generate activity. Within about 10 minutes, maybe less, that will show up in the CloudTrail logs. Then within 12 minutes, our Athena query is going to run. So like somewhere around 20, 30 minutes is where I should get my email alert. And then I'll show you what that looks like. And you can see all the cool transformations we did and what that looks like in the ASFF. Okay, in like a half an hour or so, depending on how long it takes, you should get one of your Security Hub alerts in your email. And this is pretty cool. This is the Amazon Security Findings format. And you can see that it's got some pretty readable details. So when was it observed? The title of it, the description of what was going on. So there was, in this case, we found that, and you're going to get one of these for every user. Although in this case, it's just going to be the test failure generator role that we made. 45 failed API calls. When was the first failure? When was the most recent failure? It's got a lot of cool information in here. Okay, once you've looked at this and you feel happy that you've seen it, go back here. This is that CloudFormation stack where we actually deployed it, that ran everything, and delete. You want to delete the stack, otherwise you're just going to get a lot of alerts. I hope you like this lab. It was kind of a cool one. It took me a little while to get all of the, even using the AI to get all of the code and the different pieces and components working together with the query. But this shows you how to run timed queries. It shows you how to use sliding windows. It shows you how to format and send those to wherever you want to send them. In this case, we did it as an email. That's it. Have a great week.